So today we're looking at simple interest and compound interest. In simple interest, well, first of all, let's look at how if we just save money in a bank, put in a saving account, and the bank will pay us an interest. So they have an interest rate, and a lot of times they call annual interest rate. So they do that at end of every year. Now there's a so you have something like say that the first year, or let's say this is the first year, and we have this is a beginning balance. And we know we have an interest rate. Let's say we'll have 6%, which is actually pretty high, but we just use that example. And then we'll learn how much interest we got. And then the ending balance. Yeah. Okay. So let's say you start with 100. Now the interest rate is 6%. Therefore, well, actually we can put them as 19. So the interest rate is 6%. How much interest we got? So it's basically is 100 times 6%. So that will equals $6. So that our ending balance will be 106. And now we're looking at second year. The second, for the simple interest, so simple interest, that means the interest only apply to the beginning balance. That's how much money you put in the bank. So that's your money you put in the bank. And the interest you gain for the simple interest, we're not going to take interest on the interest. So even though this is 106, but when we calculate the interest, we're still using the beginning interest, how much you put there in the first place. 6, that's still 6. Now we got 112. So this part is always this column, the interest column, is always the same year after year. It's always your initial balance times the interest rate, 6%. Now, if we go third year, then we start that third year, 100, 6% is still 6. That's 118. Fourth year, we start with 118 and still 100 times 6%. So we just keep using the initial balance, how much money you put in, you gave to the bank. So basically, the bank will take your money and combine with other clients, the money they put in the bank, then you use that to invest on something so they can earn more than 6%. So that's how they make money that way. And we got 124. Now the 50 year. So we look at the 50 year. And 124, and that gave us 106% and equal to 6. So 130. So this is a simple interest, and it's always multiply. The interest amount is always the same, it's fixed. So it's always whatever your initial deposit and times the interest rate. So therefore, if we want to know what happens in 10 years, after 10 years, that become pretty easy after 10 years. Because if you look here, second year, we basically just have interest from first year, second year is 12. So a 12 at 100 is 112. On the third year is 6 plus 6 plus 6. That's 18. Add to the initial deposit is 118. So you can see that if you found 10 years, let's say we start at $100, we know the interest rate is 6. Now, after 10 years will be the interest you got. So now you have 10 years interest, each year 6. So after 10 years, that's just that times that. That's 60. So then 100 at 60, 160. So that's how much you got after 10 years. If you after, like, say, 15 years, you simply just 6 times 15, and that give you 90. So you got 190 your balance, ending balance. So finding the simple interest is pretty easy. It's just like the interest rate, which is 6%, times your initial deposit, and that's every year you get that amount. So how many years you put in there, just multiply the number of years, and that your total interest, then you add that back to initial balance, just like we did here. After 10 years, you got 60, that's interest. At 100, 160. 15 years, 6 times 15, 90. Then we got 100, that's 90. Then add back the initial deposit. Now in your bank account, you have 190. So now we're going to looking at something which is different from here. That's something we call compound interest. A compound interest, it's a good deal if you are if you put money into a bank, or maybe you put money into some kind of investment, and normally you get some idea like how much, what's percentage you can make per year. So now we're going to look in this one, the same interest rate, 6%, and the same initial deposit. So we still follow this. This is first year, second year, and third year, fourth year, and fifth year. So now we're going to see the difference. Okay, so our the beginning balance is B and B, beginning balance. And here is our interest. Remember, we do like 6%. And there's our ending balance. Okay, 100. Now the first year is the same, just 6% times 100, and that gave us 6. End up with 106. Now for the compound interest, we're doing compound interest. So that we got interest on our deposit, first initial deposit, and also we also earn interest on our interest. So we're beginning balance second year 106, the same, but instead of 100 times 6%, we actually using the new balance. There will be 106 times 6%. And what's that? We can use our calculator to find it. So 106 times 6%. And that 6.36. And we got, now we have 112.36 that 36. Now, not much a difference. You just after the second year, you get like 36 cents. I mean, that's reasonable because the interest on the interest, but the interest from previous year is only 6. So 6 times 6% is really not that much. Okay, now we're going to looking at 1, 1, 2, 3, 6 now. Now we're going to use the new, not instead of the using the initial deposit, we using the new balance here. So 112.36 times 6%. And that gave us 112.36 times 6%. So we got 6.74. Okay, add back to 100. 112.36 add 6.74. That gave us 119.1. Now it's just like $1.01 more. So in the beginning, it doesn't seem much a difference. It's only when you're going to after like 10 years, 15 years, and 20 years, you're going to see that a difference. So, okay, fourth year, 119.1. Then we're going to 119.1 times 6%. And what's that? 119.1 times 0.06. So that's just $7.15. That add 119.1. 119.1. We got 126.24. I think it's 25. Yeah, around it. Now we're going to 126.25, then 126.25 times 6%. That equal to 126.25 times 6%. That's $7.58. 58. So you add 126.25. You add 7.58. So you got 133 and 0.83. Now, so far it doesn't seem much a difference. So at the end of fifth year, you only got $133.83 compared to 130 and just $3.83, which is not that much. But what make a huge difference is over time, along, like say 10 years, 15 years, 20 years, 30 years, 40 years, even like 50 years. So we're going to look at the difference between these two over a long period of time. Okay, so kind of a recap a little bit. One is the simple interest, and this is a compound. Simple interest, let's say you have $100, and the simple interest, we go back using 6%. And we know the interest, 100 times 6% is just $6. So it becomes easy. after how many years? Let's say n is number of years. So the end balance is basically 100, our initial deposit, add the interest rate of interest, which is $6 times number of years, and that's it. So if it's n is 10, we have 100 plus 6 times 10, that's number of years, that's 160. If n is 20, then that'll be 100 plus 6 times 20 is 100 plus 120, and that gives us 220. Okay, so that's, we'll understand that's on this side. So the formula is very simple. It's, if you rewrite it, is the principal, or in this case, our initial deposit. If you use a letter, we use P, and adding the interest, which is principal, times the interest rate, in this case is 6%, then times number of years. And that is our formula. Okay, now for the compound interest, the formula is different. And okay, so on the simple interest is the principal plus the principal times the interest rate, 6% times R. And sometimes if we do algebra, we'll write as the balance, final balance is equals to the principal times the rate, R, which in this case R is 6%. But if we want to account other kind of interest rate, we just use a letter R, then times number of years. So that's our formula. And in a way, you can rewrite this as P1 plus R times N and over that. Now, let's say compound interest is a little different. Compound interest, the formula is B equals to the principal, then 1 plus R, which is the interest rate, over number of years. Now it becomes exponent. So that's a difference with that. So we can compare that one side and one can just rewrite it in a way that we can compare. One is P1 plus Rn. So the n, number of years, is inside, is multiplied rate. For the compound, the n is an exponent. So this is a simple. So now we're going to go back to our previous example. Our principal is 100. Our rate is 6%. And we're looking at number of years. So let's compare this side and see. We're looking at 10 years, 15 years, 20 years, 25 years, and 30 years. So we see a difference. So this is a simple. This is a compound. So the simple one would be 100 times 1 plus the interest rate is 0.6%. Well, sorry, 6%. Let me actually write on the top there. Let me see. I can just write here to make that bigger. So on the simple, we got 100, 1 plus 6% times number of years. In this case is 10, and that equal to, so we can use a calculator to do that, or we can write as 100. Okay, I got 6% times 10 is 0.6, plus 1 is 1.6. So 100 times 1.6, that's pretty easy, 160. That's after 10 years. Let's look at what happens after 10 years. It's 100, 1 plus R, which is 60, 6%. 6% is also equal to 0.06. So it's 0.06 to the 10th power. And that we have to use a calculator. So it's basically 1.06 to the 10th power to the 10th power. And let's go 1.79 times 100. So we got 179 and 08. Yeah, so it's not that much. And after 10 years. Now, how about after 15? So it'll be 100, 1 plus 6% times 15. And what we got on that? So 0.06 times 15 plus 1, 1.9 times 100, that's 190. 190. On this side is 100 times 1 plus 0.06. So this one inside is the same from last time. So we can write that as 1.06 to the 10th power, 15th power. So let's see what that. 1.06 to the 15th power. That is 2.4. So 2.4 times 100 is 240. So now you can see there is difference now, $50 difference. Let's see how that goes for 20 years. 20 years will be 100, 1 plus 0.06 times 15. And that gave us 15. The 0.9, then plus 1 is 1.9. Oh, sorry, it's 20. Not, this should be 20. It's not 15 anymore. This should be a 20. 20. So that means that's 1.2 plus 1, 2.2. So times 100, 220. Now on this side, it's going to be 100, 1.06 to the 20th power. Let's see how big that is. Is 1.06 to the 20th and times 100. That's $320.71. $320.71, I think. 71, yeah. So now you can see quite a difference of 20 years. It's about 100 difference. So, and also remember, your deposit is only 100, but now on the compound interest, you actually got 100 more after 20 years. Now, how about 30? So we can skip 25, just go to 30. And that is 1 plus 0.06 times 30. So 3 times 8, 18.06 times 30 is 1.8 plus 1 is 2.8. That is become 280. Now on this side, 100, 1.06 to the 30th power. That is 1.06 to the 30th. Now we got 5.74 times 100. is $574.35. So now, after 20 years, that side is more than doubled on this side. So this one just show you the power of compound interest. Even though at the first you don't see much difference, but as time goes, the compound interest will generate a lot of money than just simple interest. All right. I hope this is helpful to you, and I'll see you next time.